Continuing on with Chapter 17, page 510 starts to talk about two different kinds of classifications of pollutants. One is industrial smog and the other is photochemical smog. So industrial smog, you can see, is from burning coal and oil, and you have smokestacks here from a factory or a power plant. And we call industrial smog gray smog, and the main pollutants for industrial smog are sulfur dioxide, particulate matter, and carbon dioxide. On the next page we have the other kind, which is photochemical smog, and you can see here it comes from burning gasoline in vehicles. And we nickname this one brown smog because it looks brown. The word photo means light, like photosynthesis needs light. And what happens is that the smog here, and you can see this UV radiation from light, will hit this pollution and turn it brown. And this type of pollution is mainly from transportation, burning gasoline. It's either nitrogen dioxide or nitric oxide, which we call NOx. Ozone, O3, and VOX, volatile organic chemicals, are the three that are photochemical smog pollutants. China and India, and actually Iran too, are the three main countries that have really horrible air pollution. And this is new since your book was printed. It's from car burning, from cars, from industry like burning coal. In China, they use a lot of electricity from coal to run their factories to make all our cheap stuff here. Agriculture and wood burning. In a lot of these places, they still burn wood for cooking or for heating. And we have this 2-mile thick layer of pollution that has been nicknamed the Asian brown cloud or the atmospheric brown cloud. And this is a new term since your book was printed, but it's an important term to know. Turn to page 512. We talk about ozone thinning. So a lot of people call it the ozone hole, but technically it's stratospheric ozone thinning. So if you remember back to the layers of the atmosphere, and I'm going to turn there right now, to the layers of the atmosphere, back on page 499. Ozone here is in blue. We have ozone down here in the troposphere where we breathe. And that is actually an air pollutant because ozone, no matter where you breathe it, is harmful to the health. It causes asthma, respiratory problems, and lowers the immune system. In the stratosphere, we want it. There's a lot in the stratosphere. We want that ozone up there because it blocks UV light and prevents skin cancer. Because too much UV light from the sun causes skin cancer, the ozone blocks that UV light. So up here, ozone is great. Down here, it's not great because this is where we breathe and it's an air pollutant. So it's the same molecule, it's just here it does us good and here it does us bad. Because here, we're not breathing it, and it's blocking UV rays. But down here, we breathe it, and it's causing us problems. Well, how come this layer up here is thinning? It's not technically a hole, it's a thinning. So let me go back to that page where I was at. Here it is. All right, it is caused by something called CFCs, chlorofluorocarbons. CFCs, the chemical formula is CCl2F2. Sometimes in the AP test, they use CFCs. Sometimes they use this. They all mean chlorofluorocarbons. The chlorofluorocarbons take oxygen atoms away from O3 and turns it into just plain O2 oxygen. And that's bad because then we don't have O3 because it's the O3 that blocks the UV rays and prevents skin cancer. So because of that, more UV rays reach the earth, which cause skin cancer, crop damage, and a loss of productivity of the earth's plankton. So these are human health problems, and these two This is an economic problem, sorry. Crop damage is economic. And this is an environmental problem. Sometimes on an FRQ, you'll need to describe health problems, human health problems, or an environmental problem, or an economic problem. So here's an example of each that you could write about. So where did CFCs come from? Well, you can see the picture here. They used to be in older refrigerators, aerosol cans, and air conditioners. They've since been banned. But what happens is that the chlorofluorocarbons, they split the ozone into just regular O2 oxygen. So we've banned CFCs in 1987, the Montreal Protocol, and so many countries came together to ban CFCs that we really are now repairing our ozone hole layer, the thinning. And it is considered the biggest environmental success story because a lot of countries came together to solve an environmental problem. Page 514. So remember, tropospheric ozone is bad because it's air pollution. It's a problem. Stratospheric ozone is good because we don't breathe it and it protects us from UV rays. So remember this, tropospheric ozone is bad, stratospheric ozone is good. Why does the ozone hole center over Antarctica? And when does it peak and at what seasons? All of these details are important and they're not in your book. You need to know the ozone hole damage peaked in 2009-2010 because the CFCs before the ban finally reached the stratosphere. So the ban happened in 1987, but all of the ozone, the CFCs made and used before 87 travel up and finally hit the atmosphere in 2009-2010. Since that time, the ozone thinning has been reversing itself. Now, it's worse in the Antarctic spring, which is actually September because the southern hemisphere has opposite seasons than us. So around September, which is their spring, it's the end of the Antarctic winter. The ozone thinning is the worst because there are more ice crystals that promote CFCs taking the oxygen atoms. So ice crystals make this process happen. The chlorofluorocarbons have chlorine atoms, and ice crystals initiate them to break apart ozone. So Antarctica is really cold. In fact, it's colder in Antarctica than it is in the North Pole because Antarctica has this huge continent that's full of ice. And so it's colder there, and there's more ice. And it's the ice crystals in the atmosphere that cause the CFCs to take the O atoms. So the very end of winter, you have this buildup of ice that's thinned the ozone hole. And that's why, again, at the end of the winter, which is September, which is the beginning of the spring, is when the thinning is the worst because you've had all that winter time to thin the ozone hole. And I know this is a lot of information, it's kind of complicated, but wrap your head around it, read it over a few times, and let me know if you have any questions. The next environmental problem, by the way, the ozone hole has nothing to do with global warming. A lot of students, a lot of people in general, a lot of adults mix them up, and they are not related at all. Acid rain. Okay, so acid rain is from burning coal or oil. So if you burn coal, you get sulfur dioxide. If you burn oil, you get nitric oxide. It mixes with water and oxygen and oxidants, and you create either sulfuric acid or you create nitric acid. This paragraph here that is highlighted tells the effects on ecosystems. Make sure you can write about the effects: damaging agricultural crops, eating away stone buildings, eating away at cars, erasing the writing from tombstones. Those are your ecosystem and your just environmental effects. So with acid rain, which technically the AP test will call it acid deposition because it doesn't have to be rain. It could be snow or sleet or hail. So the technical term is acid deposition. The biggest culprit is burning coal, sulfur dioxide, but we do have some from nitrogen dioxide from burning petroleum oil. Water buffering. Okay, so you have acid rain falling into a body of water. If the body of water is able to maintain its pH with the addition of acid, it has good buffering ability. So a buffer is something that allows the pH to remain stable even with the addition of acid. 516, acid rain clouds blow north into Canada from the U.S., and this creates political problems because Canada did not pollute the air, we did, and the atmospheric winds blow it to Canada, and they don't like that very much, and you can't blame them. Here are the equations. You can pause and write them down. For coal, it's a two-part equation. For oil, it's a one-part equation. That's a little h in there, so you know. Now, do you need to know these equations? Oftentimes on FRQs, they ask you to write an equation. You can still pass an FRQ without the equation, but memorizing them is sometimes helpful to get extra points. Turn to page 518. We can see the map of acid rain and the pH of rainfall. Now, it's much, much, much worse in the eastern half of the United States, and that has to do with the fact that the eastern United States burns coal and the western really doesn't very much. In California, we hardly burn any coal. We do burn a lot of cars, but again, coal is worse. Sulfur dioxide from coal is much worse to produce acid rain than the NOx are, which come from cars. So really it's the coal-burning states that have the worst problems with acid rain than the western United States. Indoor air pollution is also a problem. You can see in South Africa, families cooking indoors. All right, so page 521. Let me move this up a little bit. Indoor air pollution. All right, the number one cause of death from indoor air pollution in developed countries like the United States is cigarette smoke. Number two is radon. In a developing country, poor countries, India, African countries, etc., the number one cause of death from indoor air pollution is indoor cooking fires. So if you're going to die from an indoor air pollution, number one would be cigarette smoke, and number two is radon. In the U.S. and other developed countries, if your cause of death is from indoor air pollution, in a developing country, it is from an indoor cooking fire. All right, let's talk about radon again. We talked about it in Chapter 14. Let's go over it a little bit more. This is page 522. Radon, again, is naturally occurring in the bedrock from the decay of uranium. It's found in basements. It causes lung cancer. To remove it or mitigate, now mitigate means fix a problem. You can install a vent pipe system and a fan to suck radon out of a building, and you can also build a ventilation system. So these are two ways to fix the radon problem. Sometimes you're asked to write about mitigating or fixing a problem on an FRQ. So this would be a way to mitigate radon. Over here we have sources of indoor air pollution. Make sure you know the picture and the sources. Also, ways to mitigate or fix indoor air pollution. Open your windows. A lot of plants, indoor plants, absorb indoor air pollution. Choose volatile organic chemical-free paint and varnish. Don't smoke. Choose less toxic products. And no fires indoors. And those are ways to fix indoor air pollution. And last but not least, quickly, the health effects of indoor air pollution: asthma, skin allergies, infectious disease. Make sure you know about Legionnaire's disease for the AP test. It's a bacteria found in hot water heaters and spread in the air currents. Nasty stuff. And then the last thing, sick building syndrome. When people get sick and they can't figure out why. Perhaps it's microbes, perhaps it's something else, some indoor air pollutant. And that is the end of Chapter 17 Sticky Notes.